This is a continuation of our exponents quiz review for Unit 6 in Algebra Honors. This video is going to start with number 12. And again, we are solving or simplifying all of these expressions, and we want to have only positive exponents when we finish. So looking at this problem, 2y all to the negative 4. We want to remember to distribute that outer exponent to every exponent we can find inside. So remember, everybody wants a power. 2 to the power of 1, it's an invisible 1, but there is an exponent there, y to the power of 1. So sometimes I'll write those exponents just to remind myself that I have to distribute that outer exponent to every exponent inside. This equals 2 to the 1 times negative 4 is negative 4, y to the 1 times negative 4 is negative 4. And I want to rewrite that. I want to imagine that I had a fraction where that was all over 1. Anything that needs to have a positive exponent is going to change locations according to that fraction bar. So 2 to the negative 4 will go to the denominator. Y to the negative 4 will go to the denominator. And I am left with just 1 because we are dividing. 1 over 2 to the 4, y to the 4 equals 1 over 16 y to the 4. Another way I could solve this problem is I could say that I started with 2y in parentheses to the negative 4. I can rewrite this as 1 over 2y to the power of 4. So I've just taken care of making my negative exponent on the outside positive. In this way, I now have 1 over, when I distribute that exponent of 4, it'll be 2 to the 4, y to the 4, and that also equals 1 over 16 y to the 4. And one more final way to look at this is if I imagine that I have 2y, all in parentheses, to the negative 4. If I change that so that it is 1 over quantity 2y raised to the 4th power, I can expand that out, and I can remind myself that this is y, that 2 also gets the power. This is the same as 1 over 2y, times 1 over 2y, times 1 over 2y, times 1 over 2y. So I have just multiplied everything times itself 4 times. And I see 2 times 2 is 4, times 2 is 8, times 2 is 16. So I now have 1 over 16, and then y times y times y times y. I keep my base y, and I add 1 plus 1 plus 1 plus 1, and I get y to the 4th. So that'll be the same answer, 1 over 16 y to the 4th, solved sort of 3 different ways. Okay, moving on to number 13. I will simplify anything that I can simplify first. So I know m to the 0 is just 1. So that's just 1. I'm going to rewrite this and give myself a fraction bar, and I'm going to put anything that has a negative exponent in the opposite location on this fraction bar. So I have 4 squared all to the negative 1. I'm going to make that 4 squared to the positive 1 in the denominator. I don't need to write a positive 1 exponent though. I have m in the numerator. I have n to the negative 3. I'm going to put that in the denominator. Now it becomes n to the positive 3. I have 2 to the negative 3 in the denominator, so I'm going to put that in the numerator as 2 to the 3rd. And I have n to the negative 1 in the denominator, so I'm going to put that in the numerator as just n to the positive 1, or n. So now, I'm going to simplify this. We like to have our numbers in the front, so 2 to the 3rd is 8, and then I have mn. Down here I have 4 squared, that's 16, and I have n cubed. I'm not finished because I can see that I have more things to simplify. I can simplify 8 over 16, and I can simplify n over 3. So down here I'm just going to rewrite that. I have 8mn over 16n to the 3rd. So one way I can do this is I know that my new fraction bar is going to have 8 divided by 16 is really 1 divided by 2. M will stay the same. N to the power of 1 over n to the power of 3. I realize that I'm going to say 3 minus 1 is 2, so I have n squared, and I'm going to keep that wherever my larger exponent was. In my numerator, I have 1 times m, which is just m. In my denominator, I now have 2 times, this is n to the power of 2. 3 minus 1 is 2. And again, there's more than one way to solve this problem, but we should end up with m over 2n squared as our final answer. So finally, we're going to solve problem 14 here. Problem 14, I can see that I have outer exponents that I have to deal with before I can do any simplifying. So be careful here. You need to take care of these outer exponents before you can simplify inside, with one exception. H to the 0, anything to the 0 is 1. So we're just going to make that 1 to start off. I'm going to distribute this outer exponent to absolutely everything inside. Remember that because negative 2 is inside the unit that's being raised to the power of 5, you can imagine that that negative 2 is in parentheses. So I will now have negative 2 to the power of 5. I'm going to distribute that 5 to my g to the 5th, so I will have g to the 5 times 5, that's 25. I'll distribute that outer exponent to h to the 4th, so that's going to be h to the 4 times 5, so that's h to the 20. In my denominator, I'm going to distribute again. That 2 goes to 8. Don't forget your coefficients. So 8 squared. 2 goes to this g to the 7th, so it's going to be g to the 14th. And so now I can simplify further. I know that negative 2, all raised to the power of 5, is going to be negative 2 times negative 2 is positive 4, times negative 2 is negative 8, times negative 2 is positive 16, times negative 2 is negative 32. So negative 2 to the 5th is negative 32. And g to the 25th over g to the 14th, I know that's going to be g to the 25 minus 14, so that's 11. H to the 20th doesn't get to change. In my denominator, I still have 8 squared. 8 squared is 64. So, oops, you can't see that. 1 second. So I still need to simplify, and so I'm going to continue on. And I will simplify by saying I know negative 62 over 64 is really negative 1/2. So I still have a fraction, negative 1 over 2, and I have g to the 11, h to the 20. Erase that. G to the 11, h to the 20. And of course we like to rewrite that without the negative 1. We can just say negative g 11 h to the 20 all over 2. Or we could say negative 1/2 times g to the 11 h to the 20. Those are the same thing. Solving number 15. We have an outer exponent, and we have a complicated fraction inside those parentheses. I'm going to simplify inside the parentheses first. So I'm going to say that this all equals, we have a new fraction, 7 over 21 is 1/3, 1/3. G to the 8th over g to the 13th. I'm going to keep that base g. I'm going to keep it in the denominator because my larger exponent is in the denominator. 13 minus 8 is 5. This is all still squared. You could also simplify this by saying 7g to the 8 over 21g to the 13, all squared. I'm just rewriting the problem. You know that that's going to be inside your parentheses. 7 over 21 is still 1 over 3. And you could say that this is 8 minus 13, so you would have g to the negative 5. And that's all squared. That is also a way that you can solve this problem using the algorithm where you keep the base and you say the numerator's exponent minus the denominator's exponent. But you'll see that you're going to end up putting that g in the denominator anyway. So if I solve the upper equation, because I've already got g in the denominator, I'm going to distribute this exponent of 2 to every single factor inside. So I have a 3 and I have a g to the 5th. 1 squared over 3 squared g to the 10th, because 2 times 5 is 10. And that equals 1 times 1, which is 1. 3 squared is 9, and g to the 10th stays as g to the 10th. So that would be our answer. We like to write our negative either to the left of the whole fraction or in the numerator, so I would prefer to see that as negative of 1 over 9 g to the 10th, and g to the 10th has to stay in the denominator. Okay. So looking at number 16. Number 16, we have 6 over 7p to the 7th, and that's all raised to the power of negative 2. So one of our rules says that if we have a negative exponent that is being applied to a fraction in parentheses, we can flip our fraction upside down and find the reciprocal. And that would change our exponent to be a positive. So by following that rule, I'm going to flip my fraction upside down. So I have 7p to the 7th in the numerator now and 6 in the denominator. And that changes my exponent to a positive 2. So now I will distribute that 2 to every single exponent that I can find inside. So remember, we have a positive 1 and we have a positive 1. I end up with 7 squared, p to the 14, all over 6 squared. And of course that simplifies to be 49, p to the 14, over 36. Another way to solve that problem. The long way to solve that problem and prove to yourself that you're allowed to flip that fraction bar upside down. If I have 6 over 7p to the 7, all raised to the negative 2. You know that that really equals 1 over that whole fraction to the positive 2. So all I did was I rewrote that and I put this piece of information in the denominator. This really means 1 divided by that fraction. 6 over 7p to the 7, all squared. 1 over 6 over 7p to the 7th, all squared, equals 1 divided by that fraction. We can't do this division problem unless we distribute that exponent. So it's going to go to every single factor inside there. So I will have 1 divided by, in parentheses, 36 over 49p to the 14th. And we know when we're dividing with fractions, we like to see a fraction divided by a fraction. So now I'll use my keep, change, flip rule. I keep my fraction that I start with, change to multiplication, and flip over to 49 to the 14th. All over, 49p to the 14th. Too many things. 49p to the 14th, all over 36. So that should be my answer, and that should be the answer that I had gotten once before, 2 different ways. So once before, 49p to the 14th over 36. We can just find that answer 2 different ways. Whichever way you are more comfortable with is fine.